To solve this, let's go ahead and draw our river. And we need to use the distributive property over here on the right side. So 6 times x is 6x. Bring down my plus sign, and then I need to multiply 6 times 2, and I get 12. And then I'm just going to bring down everything on this side since there's really nothing I can do with those. All right, so at this point, our next step is to always get our x's together. In an equation where there's an equal sign, it really makes no difference which side the x's go to. In an inequality, we've talked about how it's really helpful to have your variable come first, to have your variables on the left side. So that's how I am going to move some stuff around. I need to take this 6x that's over here on the right, and I need to move it to the left. So how do I take away 6x? Well, I do exactly what I just said. I take it away. I subtract. So when I do that, these cancel out, and the only thing that's left on the right side of my inequality is 12. Over here, the 28 is just hanging out, but I've got some work to do here, okay? I have a minus 2x and I'm subtracting 6x, which means I'm going to need to leave, change, opposite. And so now I have a negative 2x plus a negative 6x. So the signs are the same, negative and negative. I add them and I get negative 8x. So this is my inequality now. 28 plus negative 8x is greater than or equal to 12. All right, now I've got a lonely guy over here and a Klingon. Get rid of the lonely guy next by, I'm going to keep on with my river, subtracting 28 from both sides. These cancel out, and I'm left with negative 8x. I don't really need that plus sign because it's really not necessary. I'm left with the same symbol, greater than or equal to, and again, I need to leave, change, opposite. In this case, we have a positive 12 plus a negative 28. The signs are different, so we find their difference, which means we need to subtract them. 28 minus 12 is 16, and it's going to keep the sign of the quote-unquote bigger number. So 28 is going to win this battle. I get a negative 16. At this point, I'm at a one-step equation, or excuse me, inequality, one step. Okay, so now that I have my arrow, I'm going to scroll down here. Now I can perform my check. And I'm going to choose anything from the arrow. So I don't want to choose 2, but anything from the arrow will be good. And 0, of course, is the hero. Anytime I can use 0, I do. Luckily, I can. So that means that anytime I see X, I'm going to put parentheses with a 0 inside. Everything else is going to come down, so I'm going to change colors there. And instead of these being parentheses, I've already got parentheses, I'm going to make them into brackets. And now I do the work. Okay, order of operations on the left side, I don't subtract first, I multiply. 2 times 0 is 0. And so now when I have 28 minus 0, I wind up with 28. Over here, order of operations says I do whatever is inside the brackets first. 0 plus 2 is 2. And then my last step would be 6 times 2, which is 12. I don't ever flip the symbol in my check. Remember, we only flip symbols when we are multiplying or dividing a negative on both sides, which means we're in the process of solving. We're like undoing something. In our check, we're just doing the math, guys. We don't switch or flip or do anything with that symbol. We're just proving that our number works. And thankfully it does, because 28 is larger than or greater than 12. So I'm 95% sure I'm right.